Lastly, let me issue a word of warning here. Because a single point may have many representations in polar coordinates, including negative values for r, it makes it very difficult to find all of the points of intersection of two polar curves algebraically. So it's very important to draw the two curves and have some idea of how many points of intersection they have. Suppose I want to find all possible points of intersection of the curves r equals cosine 2 theta and r equals 1/2. So if I draw these curves, I get r equals cosine 2 theta gives me this 4-petaled flower, and r equals 1/2 gives me a circle with radius 1/2. So it's pretty clear from the picture that there are 8 points of intersection here. And if I want to solve where the two curves meet, I set the r values equal to each other. So I get 1/2 equals cosine 2 theta. But this circle also obeys the equation r equals minus 1/2. So the graph of the equation r equals minus 1/2 coincides exactly with the graph of the equation r equals 1/2. So I must also solve the equation minus 1/2 equals cosine 2 theta to catch all of those points represented with a negative r. And we see that first equation, 1/2 equals cosine 2 theta, gives me 4 angles where 2 theta equals plus or minus pi over 3 and plus or minus 5 pi over 3. And the second equation, where the r values are negative, also gives me 4 points, the points where 2 theta equals plus or minus 2 pi over 3 and plus or minus 4 pi over 3. So in all we get 8 points of intersection, and in this case, because of the way the equations are presented, it's very easy to miss those points represented with a negative r.